Hello everyone, this is uh, class 8 physical science lesson number 1 question and answers. So first question is, what is force? What changes can be produced by a force? Answer is, force is a physical, that is magnitude plus direction, physical quantity which is represented as a ratio of change in momentum divided by change in time and is generally told as force is a push or a pull that can change the state of the motion or can change the shape of the object on which force is applied. The strength of the force is called magnitude, and there is always a direction mentioned along with the magnitude. So force is a physical quantity which includes magnitude and direction, in which direction it is moving and at what force is acting on the object, in which direction, ratio of change, and the changes in the momentum. What the changes in the momentum means in the motion, how the changes are taking place, and it is divided in by changing in time. At what time what are the changes taking place. Force is a push or a pull. It may be a pull or a push that can change the state of the motion. So it can change the state of the motion. With time it can change the motion or the movement. It may be high, low, anything, and it also change the shape and of the object and also force. So what are the changes we may see with the change in time of the movement of the object? That is, we can see the change in the shape of the object, force of the object, and the direction or the motion of the object. We can see the changes. The strength of the force is called magnitude. So how much strength is applied on the object, it is called as magnitude. So force plus direction, so it's we called it as physical quantity, and there is always a direction mentioned along with the magnitude, direction, in which direction the object is moving, with what force when we applied a certain amount of force, and what are the changes taking place with the change in time. What are the changes? I will repeat: state of motion or a shape or a on which force is applied, motion and shape and direction too. So the equation becomes force is equal to ma, that is magnitude, direction and acceleration also we call it as. So ma is the main equation used. F is equal to force is equal to ma. The changes produced by the force. What are the changes produced by force? Force can stop a moving object, like kicking a football, and with our force we can stop the ball. Force can initiate the movement of an object. So with force we can also, if it is in a static position, we can by applying a force with our leg we can hit the object at rest. From rest to we can make the object into a movement. It will move. Force can change the shape of the object. So it can also change the shape of the object. And force can change the direction of a moving object. Here also you can take the example of a ball. If it is moving in forward direction, if you kick towards left, it will change its direction of moving. Force can also change the speed of the object. If it is moving in a slow, if it is we kick with the low force, it will move to a certain extent, and if we kick with more force, its speed also increases. So change in the speed also takes place. And whereas shape you can say force can change the shape, means you can take an example of a let's say Okay, I didn't, my mind is not coming. Okay, when it clicks in my mind, I will just tell you. Okay, force can rotate an object at rest or motion. So force can also rotate an object at rest. So it can also rotate an object if it is in rest or a motion. Here also you can take a example of a ball. If it is rest, we can rotate as well as we can, if it is moving, it also rotates. So this is the second question. State an example of a situation mentioned below in which a force changes the speed of an object. Here we have the change in the shape of an object example. Okay. So speed of an object. How? How can the speed can be changed? Kicking a football. We can make the football move from rest, or we can change the speed of the moving ball by kicking it. Now, how the shape of an object changes? Stretching a rubber band. Yes. Okay, this one. Stretching a rubber band. When we stretch a rubber band, its shape gets changed according to the applied force. We can enlarge its length or can make it small by squeezing it with some force. And you can also take the example of a sponge, squeezing it. You can just squeeze it in that way. We can also change its shape. And a dough, if we make a round ball for making chapati, when we apply force with a pin, and it will just flatten and the shape changes from a ball to a round shaped chapati. So the force changes the shape. Cricket batsman. Third question is change the direction of an object. How can a force change the direction? The batsman hits the ball with his choice. He can either change the direction of moving ball entirely by hitting the ball towards batter, or he can just touch the ball firmly or at a periphery to hit it side swards. Okay. How can you differentiate between a contact force and a force at a distance? Contact force means when two objects are contacted. Okay. And force at a distance, that is field force. In earlier video we discussed that only. To differentiate between these two forces, we must first understand the meaning of them. So what is contact forces? Those forces in which there is a physical contact between the surface on which force is applied. We saw the toothpaste and a brush. By squeezing the toothpaste, the paste comes out. That is a contact, physical contact with the toothpaste. So that is a contact force. Non-contact force, those force in which there is no physical contact between the surface and the force acts between them from a distance on which force is applied. Magnetic force we saw, that is non-contact force. Electrostatic force and a gravitational force. Hence, to differentiate between these two forces, we must look for physical contact between the surfaces. If there is a physical contact, then it is contact force, otherwise it is a non-contact force. Next question. Give two examples each for a contact force and a force at a distance. Examples are for contact are friction force. For this force to operate, the two rough surfaces must be in contact. And for normal force, for this force to operate, to contact of the object with the earth directly or indirectly must be there. Friction force means take an example of a bicycle. So rough surfaces must be in contact. Or you are just have a placed a ball on a rough surface. Contact force, we can say frictional force. You placed a ball on the rough surface. And a normal force means you have kept a book on the table. So that becomes a normal force. For this force to operate, the contact of the object with the earth directly or indirectly must be there. Okay, that is the normal force. Non-contact force, magnetic force. We have seen magnets to repel and attract themselves without any contact between them. And gravitational force. When we jump or when we throw something up, Earth exerts a force on us called gravity and pulls the things down, even when we are not in contact with Earth. So gravitational force acts on all the objects present in the on the Earth. Detect the errors in the following statements and rewrite its making necessary correction. Because the car is at rest, no force are acting on it. So is it correct or wrong? Let's see. To get the statement correct, we must understand the concept of net force. The resultant or the total sum of all the forces acting on the body are equal to the net force. Okay, all if it is on a rest car, a gravitational force is acting upon it. Okay, and on the tire, a frictional force is acting upon it. And in direction wise, if you see x-axis, y-axis, we have seen in the chapter like that. So all together we call it as net force. So for that purpose, what we do, we see the total sum of all forces acting on the body are equal to the net force. So all the forces acting on the body should be equal to the net force acting on that body. Net force means total force acting on the body. Thus the statement can be corrected in two ways. How? First way is, because the car is at rest, no net force is acting on it. Okay. And the next is, because the car is at rest, two forces are acting on it. They are gravitational force and the normal, which sum up to 0. Okay. Gravitational force and the normal force. Why do tools meant for cutting always have sharp edges? This I have told you, I will tell you in answers. Why tools are having sharp edges. Sharp edges when force is applied on a surface area. I have told you pressure, you should remember. Pressure acting on a surface is a per unit, per square unit area. Okay. Cutting means the insertion of a thin object all along in a body so that the body gets divided into parts. Tools with thin or sharp edges allows us to concentrate or focus our applied force on less area, through which the cutting of the object starts, or we can say that the exerted pressure is more in case of thin tools. So exerted pressure, how much pressure we are applying on a edges, and if you are applied on a reverted area, so the pressure exerted on the sharp edges will be more. Though we are applying the same pressure, but the pressure is will be we can see the sharp edges will cut the object, whereas when it is blunt side, that object would be cut. So for that purpose, pressure is important on sharp edges or surface area. Area wise we can take it, this answer. Whereas in case of thick tools, the applied force gets exerted on a large area. Okay. Applied force gets exerted, so it exerted on a large area, and hence the pressure is distributed. So the pressure get distributed. It is, if it is a pencil, it is just the pressure is up to only the point of the pencil. But if we take the backward side, the other side, opposite side of the pencil, then the pressure is distributed and over a large area wise. That is only a pinpoint, and that is a when compared to a pinpoint, that will be there larger than the that point. So the area becomes small. So no penetration or insertion of the object happens. Hence no cutting appears. Objects change their state of motion due to the net force acting on them. Do you agree with this statement? Discuss with example. Okay. Object change their what? State of motion due to the net force acting on them. How they change their state of motion when a net force is acting on them. Agree with this statement? Discuss the examples. If F net, that is net force, is not equal to 0, only then we can say that the state of motion can be changed. If for net force is equal to 0, the state of motion can be never changed, as force is the product of mass and acceleration, and to change the speed of an object we must need acceleration. Yes, I agree with the statement. So when you always keep this in mind, when F net force is not equal to 0, we can say that the state of motion can be changed. That can be changed. And if it is equal to 0, then the motion can never change, as force is the product of mass and acceleration. And the changes the speed of an object, we must need acceleration. When you push a heavy object, it does not move. Explain the reason in terms of net force. Okay, when we push a heavy object, it doesn't move. How? Why? When any object is at rest and we try to move it, the force acting on the object are friction and the applied force by us. So the friction is acting upon it and the gravitational force acting upon it, and we are applying a force. And the friction force is applied force by us. The object starts to move only when its net force is not equal to 0. Means our force of pushing should be more. So it should not be equal to 0. It should be greater. And as we know that when the object is at rest and we apply force on it, the frictional force acting on it is the static friction, which is not constant and is equal to the applied force. So it is not static and which is not constant also. It is a static friction and but it is not constant. So it is equal to the applied force till the object just starts to move and slight frictions takes over when the object moves properly. So since it is not a constant, if we apply a more force and when it is starts moving, so what force takes place? Sliding friction takes over when the object moves properly. Then object moves properly. Only once we have to apply the force, then what type of force acts on the object? Sliding friction, and automatically the object moves. If you push a heavy box which is at rest, you must exert some force to start its motion. However, once the box is sliding, you can apply a lesser force to maintain that motion. Why? Because the sliding friction overtakes. Okay. When we try to push a heavy box which is at rest, and as we know that when an object is at rest, the frictional force acting on that is static friction, which is not constant. Okay, here also it possesses a what friction? Static friction. That's why it is not moving here and there, but it is not constant also. And static friction is equal to the applied force, and it is static friction is equal to the what force? Applied force, and increase as we increase, and it will increase as we increase the applied force till the object just starts to move and maximum value of the static friction is greater. So as we move the object, as we increase our force, its frictional force also increases. As we reaches which value? Maximum value of static friction is greater than the value of the sliding friction, which is constant, and occurs when the object starts sliding or moving properly. Then what force starts? Sliding friction, which is constant, and we can once it starts moving, then we can apply a lesser force to move the object. The magnitude of sliding friction is always less than the static friction, so it is less than the static friction. Find net force from the following diagram. Net force 8 newtons, and here 12. 10 plus 8, here 2. Here force of force, how much? Here see 12. Here 8, here equal 8, 8. Here 8 and 6, only in one direction. Here opposite direction. Here also in opposite direction. Okay. like this. Here 9, here 8. So what happens? Let's see. As we need to calculate what net force, and we know that force is quantity possessing magnitude and direction. We know magnitude and direction. Force we are possessing or the applying on the object, and the direction, in which direction, calls the magnitude and direction. So we need to consider the direction also with the numeric values of the forces applied on the block. So what we have to consider? Numeric values. Here they have given no numbers. These are called as numeric values on the blocks. The forces in opposite direction are to be subtracted from each other, and the force in same directions or parallel are to be added to each other. So forces acting on opposite direction. These are moving this object in here, and these are in opposite direction. Only C1 is moving the object in only in one direction, and all the other are moving in opposite directions. Okay. The resultant force and the objects which are moving in applying force in an opposite direction, that should get minus, and the object which are moving in the same direction should be sum. That is, we should plus it. We should add it. Okay. The resultant force will be in the higher magnitude force direction. So let's see first one. So 8 newtons and 10 newtons, they are moving in this direction. As these forces are in same direction, so this must be added to each other. So this should be added. So it becomes the 18. The resultant of two forces becomes 18. Now these are in opposite direction. As these forces are in opposite direction, so these must be subtracted. So when we subtract these two, how much we have now? 6 newtons. The answer is 6 newtons, and hence this is the resultant force. And these are in opposite direction. As these forces are in opposite direction, so this must be subtracted. 8 minus 8, 0. Hence the resultant force is 0 newtons. Now as these forces are in same direction or parallel, so these must be added. So if we add these forces, it becomes 14 newtons. The resultant force is 14 newtons, and these are in opposite direction, so we have only 1 newton. These forces must be subtracted. 9 minus 8, that is 1 newton. Here the resultant force is 1 newton. In that way, how do you increase the pressure? By keeping a area unchanged and force unchanged. How increase the pressure? By keeping what? First category is area unchanged, and second is by force unchanged. So area should not get changed, and force also should not get changed, but we have to increase what? Pressure. So let's see the first scenario. Pressure is the ratio of force divided by area, precisely the force counted in perpendicular to the area of consideration and not at any angle other than 90 degrees. So P is equal to F by A, that is force by acceleration. So pressure is equally proportional to force, and pressure is inversely proportional to area. As we know that to increase the value of friction, we must increase the value of numerator or decrease the value of denominator. So since it is inversely proportional, so for that purpose we have to decrease this, and for purpose to make the pressure increase the pressure, we should increase the force, since it is proportionally it is proportional to what? Force, and inversely proportional to area. To increase the pressure by keeping area constant or unchanged, we must increase the force perpendicular to the area. So what we should increase? Perpendicular to the area. To increase the pressure by keeping force constant or unchanged, we must decrease the area of application. So what we have to do? we should decrease what? Area of application. And here what we should do? To increase the pressure by keeping area constant. Area should be constant, but we must increase the force. What we have to increase that is force we have to increase here to the perpendicular to the area. Here decrease the area of application. Imagine that friction has disappeared from the earth. What will happen? Explain. If friction is not there. When friction will disappear from the earth, the following things will happen. The brakes of the vehicles won't work and the vehicles won't run as the driving moves force is friction. The engines gives the rotating power to the wheels. The friction makes the car move forward. So brake won't work because there will be no friction between the road and the tires. We won't be able to walk because we walk when we apply force on the ground backward and the ground applies its friction force forward. Hence we walk. We won't be able to pick objects as the weight of the object pulls it downwards and the friction counterbalances the weight and we are able to hold objects. So when we are picking something from the ground, we are able to catch them. If friction is not there, how can we hold them? We can't hold them, and it will on the object the gravitational force will pull the object onwards and we will be unable to hold the things and lift it up. We won't be able to write with pencil. As we write on paper due to friction, the pencil graphite gets traced on the paper, etc. Karthik is observing the live telecast of a one-day cricket match. He noticed motion of a roller on the pitch during lunch break. He thought about various forces acting on the roller and the net force when it is in motion. Many questions arose in his mind regarding the direction of the net force. Can you guess what would be the questions? Only questions. So it's a pitch area, or you can say a playground of a cricket. Normal reaction, force, linear motion, here weight. This is the friction. So what are the questions? What are the forces acting on the roller when the roller is at the rest and when it is moving? Does the force acting on the roller depends upon the direction of the motion of the roller? Can we get the direction of the net force when force is applied on the roller by the people driving it? Area, there more than two net forces. Are there more than two net forces? These are the questions arising in his mind. Design and conduct experiments to test few ways how friction may be reduced. In some things, in some way, some places we need to reduce the friction. So what are the experiments we can conduct? So these are the things. Friction helps us to do various works, but it is also evil. In what way it is evil? Let's see. And to reduce this evil, there are many ways that are making the surface smoother by decreasing the roughness. So if it is so rough, we can't sleep. Okay. So if it is smooth, we can sleep. So we use surface smoothers. Lubricating the surfaces. Lubricating the surfaces means we also use lubrications in fans, bearings, and everything. Okay. Surfaces. Make use of wheels, that is use rolling frictions rather than sliding friction. So what in wheels what we use? Rolling frictions rather than what? Sliding frictions. Reduce the contact and hence increase the space between the surfaces. So contact and hence increase the space between the surfaces. Object moving in fluid, that is liquid and gases, have a combination of liquids and gases called the fluid. Object moving in fluids have streamlined shapes to reduce frictions by fluids called drag. In cars, not only due to tires we can reduce friction, but due to the design of the car, that is the streamlined car, and the aerodynamics technology can reduce the air drag or the friction due to air or wind. Experiments. Smoother surface have less friction. Place a smooth inclined plane on a smooth table. Okay. What plane? Smooth plane in an inclined plane in a slanting position. Put a mark with a pen at any point A on the inclined plane. Now let a dry cell move down from this point. How far will it move? Note the distance from the end of the inclined plane. Now place the cloth or sandpaper on the table. Provided they do not have any wrinkles on them. Now repeat the above steps, that is make the dry cell move from the same point A and where it stops. When it stops, note the distance from the foot of the inclined plane till where it stops. You will observe that the cell moved larger distance in the case of smooth table surface and moved less distance in the cloth case and the least distance in the sandpaper case because of the friction. So we need smoother surface to reduce friction. How to reduce friction? By conducting an experiment. What he will do? He will just roll this dry cell. First he will incline only, but first he will put the smooth surface, then he will change into a cloth, then he will change with the sandpaper. So he will just note down the distance, and the lesser distance is traveled by the cell is when the sandpaper is used. So smoother surface reduces the friction. By this experiment we concluded that smoother surfaces has less friction. We can reduce with the smoothening the surfaces. Experiment 2. Rolling has less friction than sliding. Take a few pencils which are cylindrical, not hexagonal or trigonal in shape. Place them parallel to each other on a smooth table. Place a thick book over them and try to push the book. You will observe that the pencil roll when we push the book. Accordingly, now try to push the book when it is kept on a table directly. You will feel more effort in applying in this case than the pencil rolling one. So we need to use wheels to reduce friction. Now one more way of reducing friction is what you have to do, you have to take a round pencil. Round pencil means cylindrical pencil. It should not have any edges. And that's why they have written not hexagonal or trigonal. Just place the two pencils horizontally and place the book upon it, and just you move it, and it will, when you are moving a book, the pencils also rotates, which you kept below the book. And when you keep the book just on the table and you move the book, then you will feel you are applying a more force than the when you kept on the pencils. So rolling process also helps in reducing the friction. So these two experiments tells how to reduce the friction. Take two identical straws and suspend one of them freely. Rub the other straw with a piece of paper. Bring the rubbed end of the straw near the suspended one. What do you observe from this activity? Can you tell which type of force is it? Comb your dry hair. Bring the comb near small piece of paper. What do you observe? Explain. These all things we have done. You will also done, I think, by combing your hair and just taking a pieces of paper and just putting the comb in front of the pieces. It will just attach to the comb. That produces electrostatic charges. Okay, so let's see the answer. There are forces of many types in nature, not only the muscular force of humans but also other forces between electric charges, magnets, etc. First one, when we do this activity, we will observe that there is an attraction between the two straws but not a strong one. This type of force is called electrostatic force. It is a non-contact force. It is formed due to induction of charge by friction or rubbing. But after some time this effect disappears. So this is the first answer. And second one, the piece of paper gets attracted to the comb but the attraction is not very strong one. This type of force is called electrostatic force. It is due to when we rub the comb on our dry hair, due to friction the comb gets induced charges, and hence the charged comb attracts the bits of paper, but after some time the ability of the comb gets lost. Okay, means it won't possess any charges anymore. Collect pictures from various sources like internet, magazines, newspaper, etc. to illustrate contact forces, and prepare a scrapbook. Examples of contact forces are C. Free body diagram, FBD. Tension, pulling force. Friction, force or frictional force or friction. How? Moving force. In this way, friction. This is the friction because they are contacting with each other. Here see. How? Tension is exerting on the this mass or a object having a weight. So tension is exerted on this direction also and this direction, gravitational force, and also on the by the this mass body and the here gravitational force. It will also create the force, and this string also exerts the force on the mass, and also the on both of this gravitational force also exerts the force. So that's why it is called a tension. And free body diagram is this. Tension is a pulling force. Frictional force or a friction. So contact forces. These are the diagrams. Box sitting at rest. Set on a rest. That is a mass. This is a normal force. That is here it is a contacted force on the box. That is Fg, gravitational force, and the normal force. Both are equal. So net force becomes 0. And here tug or war game. It has a contact force mechanism. Both are just holding a rope and they are pulling, here also 2, here also 2. So then nobody wins unless and until they applied the force greater than the other. A stick is placed on steps as shown in the figure. Draw normal forces on the stick. See, inclined. It is in contact. Okay, here it is in contact, but it is in inclined position. So what are the force acting on it? As normal is the reaction contact forces which acts when there is some action force, and hence the normal reaction force should be equal to the weight of the rod, which is downward. In this situation, the normal is not operating on a single one, but it is operating on 2 points in contact with the shades. Now see, N1 and N2. N2 is slightly tilted towards N1 and N1 is straight and perpendicular to the staircase. Observe the figure below and find in which direction the force of friction acts. Also indicates the normal forces and their direction. So what is the force? He is just moving the table and he is pushing the table in away from him. So we called it as push. The frictional force, that is between the surface and the object. The frictional force acts opposite to the direction of the applied force. Opposite. He is applying and here it is the frictional force. So opposite direction. He is moving there and the force is exerted in this way, in a vertical line. Okay. Or the driving force applied by the boy on the table, because frictional force prevents relative motion between two surfaces in contact. The normal reaction force is acting on every leg of the table and is equal in magnitude, and the sum of the total normal reaction force is equal to the weight of the table acting at the center of the table. So all the forces acting on all the four legs, and it is the weight of the table, normal reaction, and this is a friction. The horizontal lines at the end of the legs, horizontal lines are these. Okay. At the end of the legs of the table are frictional forces. A man is standing still on a level floor. What force act on him? Draw a free body diagram to show all forces acting on him. He is standing on a level floor. So what are the forces acting on his body? Normal reaction force. Okay. C. Weight by the gravitational force. And see here. Two forces, upper body and lower body here. And see this. Okay. If a man is standing still on a level floor, the free body diagram of a man would have only two forces acting on the man. The force are weight of the man and the normal reaction force of the man. The arrow pointing upwards are the normal force. Upwards. These are the upwards. This. Okay. Are the normal force, whereas the arrows pointing downwards are representing weight. These three are the representing the weight. If a man is walking, the force body diagram of him would be completely different from this. Now he is standing because we have drawn like this. How do you appreciate the role of friction in facilitating our various activities? Frictional force or friction has many to do with our daily lives. Without the friction, our life would be very difficult. But the activities friction facilities are: in walking, friction and through the ground give us a forward push as a reaction when we push it. Second one is in writing, when we have to draw something beautiful, friction is there. When we move our pencil on a paper, the graphite of the pencil gets on the paper by friction and the pressure applied. So what are the material which we use in a pencil? That is graphite. Okay, and with the help of our pressure, when we are writing, we applied a amount of pressure, a little pressure, so that the with the help of a friction we can write, and it is the written form will be just printed on the paper due to friction. In vehicle motion and brakes, the friction on the road is the one that help us to move our vehicles from one place to another and help us to apply brakes whenever we want to. If we drive on icy roads where there is almost no friction, our cars won't run and also won't stop properly. There are general things we do in our daily lives in which friction is involved and plays very important role. Drifting of a car due to friction. See here. A monkey hangs stationary at the end of the vertical line. It should be line. Okay. What forces acts on the monkey? Okay, he is frictional force. He is holding. Okay. Upwards and weight downwards. Downwards arrows are the weight and the upward arrows are friction. Two forces. The weight of the monkey and the frictional force from the contact, which depends on the strength with which monkey is holding the vein. Okay, vein means they are using this stem as a vein. Okay, more the strength, more the friction. The friction will increase with normal force of vertical vein, and the monkey hand and tail acts on the monkey. Weight acts on the full body but is felt by the contact parts. In this case, it is monkey's hand. There are two forces acting on the monkey. It is the vertical it is in the vertical case only, and also if the weight of the monkeys is on the tail, there is a pulling force in the tail of the monkeys also. So these are the following questions of force lesson. Hope you understand.